All right, last page of the U sub notes PDF. Try to hopefully make this fast because now that we're pretty well steeped into understanding U subs, I'm hoping that this is a little bit more trivial. Okay, so 2 fun facts today that might be helpful. One is that the integral of e to the u is e to the u. Okay, so that's old news. The other one that might be helpful to remember is that, like, if you have e to the negative x, I don't think we talked about this back in chapter 4, that ends up being negative e to the negative x plus c. Okay, so sometimes that e to the negative x will come up in these, and you don't really, even though this, has a -1 for its exponent, the goal would not be for you to do an entire u sub. It would just be for you to kind of jot down the result here because it just kind of makes things go faster. If it's anything other than that, like if it's e to the -3x or e to the whatever, -1/4 x, then you probably should think out a u sub just so you get the constants right. Okay? But remember what this means, that we do have to do a formal u substitution for all parts of the integral when we have an exponent that is u. Like example 1 here. So example 16, again, we think of it like a composite function. It makes the most sense to let u equal 4x. So I'm going to write that down. Hopefully you can predict what's going to happen here. The du is 4 dx. And there's no 4 in the problem itself, so I'm probably going to divide by 4 here to get 1/4 du equal to dx. So now on the other side of things, when I go to rewrite this, I have my 1/4 e to the u du. And this is now that I've done a u substitution, now I can apply that formula in the box. All right, so 1/4 e to the u plus c. And then my final result is 1/4 e to the 4x plus c. So make sure the plus c is on the regular level, that it's not in the exponent or something like that. But the goal would be that you not have to do a u sub whenever we just have a little constant in front of the x, right? If it's just e to a constant times x, I would kind of like you to think globally, if you're with me here, like if it's cx, I would like you to think about dividing by that number, right? And then you'll come up with the exact same answer. So it's very similar to when we did trig work, right? Sine of 2x ends up being -1/2 cosine of 2x, right? Plus c. So same idea. So example 17 is exactly what we were talking about there in the box, in the green box. So if it's e to the -x, I just want you to very quickly be able to write down -e to the -x plus c. You can go ahead and do a full-on u substitution to figure that out if you'd like, but I don't think we need to justify it. I think you kind of get it. Example 18, again, this is a constant times 3, so if we think back to this pink formula up here, if we're going to divide by that constant of 1/3, that would actually be multiplying by 3. Right, so 3e, actually, let me put this elsewhere. 3e to the 1/3 x plus c. And if you're sitting there like, lady, I don't know what you're saying, let's walk through it again. Here's what my u sub would look like. There's no 1/3, there's no constant in front of this problem to mess with, so I'm going to multiply both sides by 3 to clear out the constant by the dx. And when I go to rewrite the original, it would be 3e to the u plus c. And when I integrate that, I get 3e to the u plus c. And when I replace that, I get 3e to the 1/3 x plus c. Okay. So it does work out. 2 different ways to go about it. Some of you, everyone's going to be at a different point on this. So some of you will go faster, to getting right to the answer. And some of you will have to do the u sub. And I love both ways. Example 19 here. Very similar. I know that we have a product times, a product with a composite in it. But if we analyze the degrees on the exponent and on the x squared, Degree-wise, it makes more sense to let u equal x cubed, because then the du is going to be 3x squared, and that x squared here, right, matches up with this x squared here. Okay, plus the dx. So what does not match is that 3, so I'm going to go ahead and divide by it on both sides. So I'll have 1/3 du equals x squared dx, so that when I go to rewrite it, I have 1/3 times the integral of what? Hopefully you chose e to the u du, right? Everything's taken care of there because the du, remember, and the 1/3 is worth x squared and dx. So I'm only integrating e to the u. Answer would be 1/3 e to the u plus c, which replacing is 1/3 e to the x cubed plus c. What a good time. All right. And then example 20. Again, the degree on x is just 1, so we know that a u sub will do just fine here because we're going to mess with the constants a little bit. So if I have 3 minus x, the du is just -1 excuse me, times dx. And now I don't have a negative in front of the e to the 3 minus x, so I'm going to shift it to the other side. So I get negative du equals dx. So when I go to rewrite this one, I've got my negative and my du is taking care of the dx, and then the rest is just e to the u. Integral stays the same, and then replacing. Yay, integration.